think we can go ahead and get started. We've got a number of participants. We've got quite a few with us right now. I would like to just welcome everyone to this presentation, Space and Vision Loss. Hopefully most of you have read the description of this presentation and what it's going to be about, but just by way of brief introduction, Dr. Steve Laurie is a lead scientist at the Johnson Space Station. His broad interests include understanding how humans physiologically adapt and excel in extreme environments, which includes how travel in space can affect vision. He also has extensive training in pulmonary high altitude physiology. He's joined in this presentation by Tracy Minish, who's worked for NASA's manned flight programs for 35 years, training astronauts and flight controllers on shuttle systems, designing math models and creating innovations in software design and training, all while legally blind. So we're so grateful for Steve and Tracy for volunteering their time to share their knowledge and experience with us today on the topic of space and vision loss. Just as a little note, if we have time for questions after the presentations, or if there's any other time to ask them, we'd ask that you key them into the Q&A function. That's the preferable way, or perhaps the chat also. We'll do our best to make use of that function as well. Or you can raise your hand and we'll attempt to unmute you and let you know that you can go ahead with the question verbally. So without further ado, you guys can go ahead and take it away. The way I understand it was that Steve was going to actually start first. Is that correct?
That is correct. And what I was going to do is just a brief introduction, just say Dr. Steve Laurie graduated with his PhD from the University of Oregon. So he's a duck. He's the lead scientist for NASA, worked there 7 years, helping the astronauts that are on the International Space Station, doing research with them. And he's looking at the issues that you have when you've been long duration in zero gravity with your eyesight. And then he's looking for ways to mitigate this so that when we go to Mars or more extended missions, how we will help our astronauts to be conditioned to mitigate those issues. So I just turn it over to Dr. Steve.
Hey, thanks Tracy and Stuart for those introductions. Really appreciate that. Let me see if I can get to my slides and get them up so that you can see them. Let's do that. Okay, can you guys see my full screen there?
Yes.
Okay.
Yes.
Great. So if you have questions along the way, feel free to chime in. Otherwise, I'm hoping to only share about 15 or 20 minutes here and then have some time for questions at the end. So if you have any questions, hopefully I'll be able to answer them. My title today here is Swelling in the Eye on ISS. Will ocular changes that develop on the International Space Station prevent us from going to Mars? And as everyone has said so far, you know, I'm going to talk a little bit today about some of the findings we've seen in our astronauts and some of the work that our team and others are doing to understand what's happening and then figure out how to prevent this from occurring on longer duration missions. Here, I think I'm going to have to, there we go. So I do work at Johnson Space Center, and this is a photo aerial shot when they were flying. This is actually a replica of the space shuttle that's on top of the 747. And if you have a chance to get down to Johnson Space Center at all, this plane with this replica is actually at the visitor center right next door, and you can see it and go up inside the shuttle. It's really a neat experience. Our team actually works in a building right in the middle of campus. It's the Human Health and Performance Laboratory. It's a brand new building about 3 years ago. And all of the human subject research that we do on astronauts is conducted out of this building. So our team does cardiovascular and vision research, but there's also groups that deal with neurosciences, human physiology, performance and protection and operations. This group deals with all the physiology related to doing spacewalks. There's a nutrition group, immunology, and anything we can think of related to the human. There's folks in this building working on that human factors behavioral performance. We also do research here, and this is a photo of the International Space Station. It circles about 250 miles above the Earth. And so we study astronauts or crew members before they go to the space station, when they come home, and then while they're aboard the space station. And I'll have a few pictures today showing you how we do that and how we are able to collect our data while they're up there acting as subjects for us. So the ISS was assembled in low Earth orbit starting in 1998, and it was completed in 2011. Expedition 1 was the first crew to arrive. That was in November of 2000. So we've had over 20 years, or coming up on the 20-year anniversary of a continued human presence on the International Space Station. NASA and our partner agencies, including Roscosmos from Russia, the Japanese Space Agency, European Space Agency, and Canada, all work together because it truly is an international research laboratory. Individuals from 19 different countries have visited the ISS, and this picture is now a couple of weeks out of date. This was the crew of Expedition 63 on the right in the dark shirts. Some of you, if you've been watching in the news, would recognize here Doug Hurley and Bob Behnken. They flew the Demo 2 SpaceX vehicle up to the space station. They got home about a week or two ago. And then right here in the middle is Chris Cassidy. He's a US astronaut. He's currently the commander of the space station. And then two Russian colleagues here. Anatoly Ivanishin is on the far left, and then in the back row is Ivan Wagner. And so those three are the ones currently on station, and we'll have more joining them here in the future. So as I mentioned a few slides ago, there's a lot of
Sir?
Yes.
There is no advancing of the slides. We're still looking at the title slide.
Oh, okay. Let's see if we can fix that. I apologize. Are you seeing it with the slides on the left, or do you see the full screen mode?
Right now, we're seeing it with the slides on the left. We were seeing the full screen of just the title page.
Okay. Thank you for chiming in. Let me see if we can fix that. So if I need to share again here. It isn't giving me the option. Well, let's see if I do the desktop, if that helps. Okay, do you see a picture of the space station here?
Yes, we got it
Yes,
now.
sir.
Okay,
Yeah,
thanks.
and I think we saw your second slide also. When you,
Yeah, so let me,
there you go.
we'll just go through here. So yeah, there was the plane, there's the building we work in, and there was the International Space Station, which I spoke to. And then the
Yes, we're
crew
seeing
was
that
on
now.
board. Okay, thank you. Thanks for jumping in. So there are a lot of physiological and psychological changes that can occur in weightlessness when individuals are there for a long time. And there's a list here of a lot of different things: bone, skeletal muscle, neurosensory, cardiovascular, psychological, environmental. And when this graphic was made, the interesting thing that if you look really closely, there are no eyes on this person. And of course, there have been a number of reports in the media about some of these eye changes that first came to light about 8 years or so ago now. And so we keep telling them they need to update this figure because there are eye changes that develop in weightlessness. So what are some of these eye changes? So we've known since the space shuttle days for 20 or 30 years that when crew members go into weightlessness, their vision changes a little bit. And they can't see as well up close. And all we've done to fix that is we changed their prescription by a small amount. 1 to 2 diopters is the most we've ever seen. And a new pair of glasses fixes the problem. And so it wasn't really that concerning because it was an easy fix. Now in 2011, the first paper was published that said, wait a minute, there may be something more going on here. And this paper revealed that there, in addition to the changes in vision, there were changes, something called optic disc edema. So this is swelling around the optic nerve in the back of the eye. Globe flattening. So when they looked at MRI images, they saw that the back of the eye was flatter. Folds in the actual retinal tissue called choroidal folds, and then cotton wool spots. And we now term these types of findings the Spaceflight Associated Neuro-ocular Syndrome, or SANS. And the most concerning of these, and the thing I'm going to focus on mostly today, is the optic disc edema. And so the first question, of course, everybody had is what is causing this finding? Now on Earth, swelling in the eye often occurs because people have an underlying pathology causing elevated pressure in their head called elevated intracranial pressure. Now, patients with this condition are often obese, female, they have pulsatile headaches and ringing in their ears. And none of these things were typical of our astronauts. And so we really didn't understand or know what the underlying cause of this was. But it is a concern because when individuals have swelling in their optic nerve for long periods of time on Earth, it can damage the eye to the point where it causes blindness and irreversible damage where we can't just give them glasses to fix it. So when this came to light, the collaborations between the space medicine group, the research arm, which our team is involved with, and our epidemiology group really set out to try and first get equipment onto the ISS in order for us to try and start figuring out what might be going on. So the first thing that flew was an ultrasound machine. This was in 2012. And this is actually just a normal ultrasound. It's a laptop-sized one, so it's not a giant one. There's nothing special about this laptop ultrasound machine that wouldn't be available in a doctor's office, except for the fact that we created this overlay over the keyboard, and there's these different colors on the keyboard. And what this is it helps our remote guiders on the ground, who are experts, tell the astronauts which buttons to push. So the buttons are numbered, and he'll say, push pink 1. And they don't have to know what pink 1 does, they just know how to get to it quickly on the keyboard. And so doing this, we were able to use remote guidance and allow the crew members to do ultrasound on each other with experts on the ground. In 2013, we launched a device called a fundoscope, and this is basically a way to take photographs of the back of the eye, and you can see a crew member here doing this on themselves. And then in 2013, we launched a new camera called an optical coherence tomography, or OCT. This camera gives us very high resolution images of the retina. And then in 2018, there was a second version of this that launched. And so the crew members are able to, basically align themselves. And myself and others will go into a back room of mission control, and we can see their computer screen and tell them how to get aligned and what buttons to push in order to capture these images. So this equipment has really given us opportunities to characterize and understand the progression and the variability of these findings to better understand what's happening. So I'll start with the fundoscope. This is this camera that takes pictures of the eye. And what we have here is a couple examples of when edema develops around the optic nerve head. And this picture on the left, you see this very crisp circle. This is the optic nerve in the back of the eye. And this is what it typically looks like on these cameras. As edema develops, the borders around that get fuzzier and fuzzier. And there's this grading system that's a 0 to 5 grading system that's been developed clinically on Earth to categorize how severe the swelling is. And the take-home message here is that we see swelling of a grade 1. We've had one individual show a grade 3, but almost everybody else has shown grade 1. So it's mild disc edema, which is, oops, let's see here. There we go. So it is mild, but it's still concerning to us. And then I want to show you some images from the OCT camera. This is a camera that uses lasers to create cross-sectional images of the retina. And so this picture on the right is actually a cross-sectional image right through the optic nerve. And so we're looking, the dip in the middle is the cup of the optic nerve, and you can imagine the nerve goes downward out of this picture, which is going back into the head of the individual. And I'm just gonna jump back and forth, and it's a subtle change, but what we're showing here is this pre to post-flight image where swelling is occurring and the layers are separating apart. And we're able to measure and quantify some of this, which has enabled us to really get a better understanding of the progression of the edema as it develops, which is more sensitive than this rudimentary grading system that's on the top of the screen. So OCT has really become kind of a workhorse for us for understanding the edema. So how do we do this? So here I am, I'm in this back room, the Telescience Support Center, about to go in, and the picture on the left is a whole bank of computer screens that we look at. And basically I get to see two different screens. One of them is a video camera feed from inside the ISS cabin. And the second is a screen share of their laptop that's running the software. And so this typically happens in the middle of the night. It's very small, but that computer screen on the bottom left there says 3:16. That's 3:15 in the morning. We're in there because they're on Greenwich Mean Time, so they're 5 or 6 hours ahead of Houston. Typically, we do these exams in the morning for the astronauts' time, so we have to get up and go in the middle of the night, but it's the middle of the morning for the astronauts. And then we walk them through getting into position and what to hit on the software and how to make the adjustments to collect the images. And over the last 5 or 6 years and a few different research studies that our team has done, we've identified that about 70% of astronauts show early signs of edema. Not necessarily clinically relevant yet, but we know that is the early signs of edema. When the crew members come home, it can take 6 months to a year for the edema to totally resolve, but the edema does resolve, so that's good. We see these findings in both men and women astronauts, and it occurs in both of their eyes. Now, luckily, we have not yet observed damage to a certain layer within the retina, the retinal nerve fiber layer, or RNFL. When edema damages those fibers, that's when it can lead to permanent changes in vision and vision loss. And we have not seen that yet, which is obviously very good, but we don't want that to occur. And the concern is that with prolonged duration missions, if this edema lasts longer during a mission, that there's the possibility that that will occur at some point. So we're collecting data now to understand how long has the edema been there, and then we track them after their mission is over and actually later into the years of their life to see if we end up seeing any of the thinning of that layer that would be signs of that damage. So I mentioned at the beginning that when this first came up, the hypothesis was that there was this elevated intracranial pressure. And we know that when we go into a weightless environment, there is a shift of fluid towards the head. And that maybe is causing an increase in intracranial pressure. And it's possible that that intracranial pressure is transmitted down the optic nerve and damages the eye, and that could be causing damage there. Now, alternatively, we said, well, there may also be a vascular effect. So with that headward fluid shift, you're going to get engorgement of the veins, and you're going to get changes in the blood flow and even the cerebral spinal fluid in the head. And that perhaps there are other effects independent of the intracranial pressure that are leading to these ocular changes. And so our team and others have tried to explore these two different hypotheses to understand what is the root cause, and therefore what might we do to target reversing this. So on the intracranial pressure side of things, there was a very elegant study done a few years ago that we don't have the ability to make this measure because it's a very invasive measure during spaceflight. But we did have a researcher that had access to patients that were cancer patients, and they had a device implanted into their brain that delivered chemotherapy into the ventricles of their brain. And that's what this image is on the left. And that device, they are now cancer-free, but that device also could have a pressure sensor inserted into it. And so these individuals were recruited, and a pressure sensor was put into this device, and they were taken on a parabolic flight. And this is an airplane that flies in parabolas and provides about 20 to 30 seconds of weightlessness in parabolas over and over. So these individuals lied flat on a bed on this plane in one gravity environment. And then the plane flew its parabolas, they would go into 0G. And so here is just a profile showing this plane was flying repeatedly into 0G, and then they would pull up on the bottom of these parabolas and they would experience almost 2 Gs of force. And they did this over and over and over again. And they had a continuous measurement of the pressure inside their brains during that, the intracranial pressure. And what they found was that when they moved from 1G to 0G, their intracranial pressure actually went down, which was a very interesting finding. And this gave us the first evidence that perhaps the ICP is not pathologically elevated during spaceflight. Now, what I don't show here, but they did do in the study, these individuals started flat and they were lying down. When we sit upright or are standing upright every day, our intracranial pressure is about 0. So every single day, our pressure transitions between 0 and say 15 millimeters of mercury. Astronauts, if the ICP in astronauts is similar to the data they show here from parabolic flight, they don't have the ability to stand up and unload that pressure like we do every single day. And so one of our hypotheses now is that while ICP may not be pathologically elevated, perhaps this chronic, unrelenting, mild elevation that's similar to the supine posture is sufficient to cause some of these eye changes that we see. But the fact that it's not pathologically elevated was an important finding for this study. So if we now shift to the vascular side of things and say, well, if ICP isn't the culprit, could it be something to do with the blood is just backing up in the veins and pushing back at the eye? So one of the studies we did recently looked at the jugular vein. So this is the large vein that drains through your neck, and it drains the blood out of our heads. And so this baseline image is some of our astronauts taking images using the ultrasound system of the veins in their neck, showing the blood flow draining their head. And so here's just a cross-sectional image of that, and I've drawn in yellow the jugular vein, the outline of it, so you can see approximately the size, the area as it is engorged when they're in weightlessness. Then the crew members went and used something called the Chibis device, and this is a Russian piece of hardware on the Russian end of the space station. It's basically a special pair of pants that is attached to a vacuum and draws negative pressure. And what that does is it helps draw fluid from the upper part of the body down into the legs. And when we did this, we saw the jugular vein shrunk in size, and we got it to go smaller, which suggested to us that we were drawing that fluid out of the head and that we were having some effect at trying to reverse that headward fluid shift. We also have, and this is another picture of those same pants that the individual has. Here they've got that OCT camera, and so there's a variety of different metrics we get out of that camera that we were able to compare when they acutely have the LBNP pants on, what that does to a variety of different, the choroid, which is a vascular bed, and how that affects the eye acutely. So that's kind of an overview on the edema side of things, the path we're taking to try and understand what's causing it and what we might be able to do to prevent that edema from developing. Next, I want to briefly talk about a second finding that we see, and those are folds and wrinkles that develop in the retina. We've seen these in about 23% of the astronauts who have flown long duration missions to the International Space Station. And here's one of these OCT images again, and what this is showing is a very smooth bottom layer of the retina, which is how the retina should look. And then this is a secondary image in which you see all of these wrinkles along the bottom, and that's not normal. And we don't fully understand why these wrinkles are developing. And in fact, this image here is hard to see because it's small, so I apologize, but we actually see the wrinkles in two different places. We see them in both the bottom layer of the retina, and we also see them in the top layer. So the top layer, they're called retinal folds. The bottom layer, they're called choroidal folds. We see both of these in our crew members at times. And these are concerning because they can, long-term, they may have an impact on vision. So these images here are pictures that were taken in a crew member. This is after 5 years that they've been home. And what we're showing here basically is what look like scars along here. And these line up with where the folds were developing in this individual. And because these folds are developing where the rods and the cones and these light sensing cells are in our eye, there is a concern that those cells are going to be damaged and could not work as well long term. So these are, luckily, these folds are not really spread across the entire retina, and we have not yet seen them enter the areas of the macula, which is really where we have our best visual acuity. But we have concerns that if some of these folds do intersect certain areas, that it could cause damage, again, that would not be reversible with glasses. So this is an area that we are investigating and trying to understand what the cause is, and if there's things we can then do to prevent these things from happening. And finally, I'm going to just discuss briefly, The crew members go up for about 6 months at a time. And so it can take a long time to collect data on enough subjects to start to understand these stories. And so for many years, NASA and others have used analogs or things on Earth that can help replicate some of the findings. One of these analogs is something called head down tilt bed rest. So this is a subject who is put in bed at a head down tilt position about 6 degrees, and they'll stay in bed for 1 or 2 months. Most of this helped us understand things with the muscle changes and the bone changes and to develop some of the exercise hardware, but we never saw the ocular changes. And so we felt like we didn't have the ability to use this analog to study this condition further. But this subject, it's hard to tell, but this subject has a pillow. In fact, that pillow is probably 2 pillows and they may be folded, and his head is actually lifted up slightly relative to the rest of his body. And so we said, you know, perhaps that is helping unload whatever is happening at the level of the eye. We should keep their head down. So we implemented a study where we said this needs to be strict head down tilt. We created a custom pillow that basically kept their head neutral but still head down. When they ate meals, they couldn't raise up onto an elbow and lift up their upper torso. They had to eat their meals even with their head down. And they stayed like this for 30 days. And at the end of the 30 days, we observed the optic disc edema in 5 of the 11 subjects. We published these findings in a couple of different manuscripts, and I'll show one piece of data, and that is that we brought them back 6 months later and they had recovered, which we were very encouraged to see. So we now had a model that we could induce similar changes that we see in astronauts in a much shorter time frame in order to test various countermeasures. So we then took a second study. We said we're going to implement the same 6-degree head down tilt, and we're going to put them on, some of them onto a human centrifuge. And we're going to spin them and create about 1 G of force at the level of the heart for 30 minutes a day, every day for 60 days. And we're going to see if we can reverse that fluid shift, help unload whatever may be happening at the level of the eye, and see if we can prevent the development of the optic disc edema. Here's that cross section again of the retina, and I'll just flicker back and forth. And if all you can see is that it's changing, what you're seeing is the development of edema that ended up still happening in these groups, and it got worse by the 60th day. And then we quantified the change in that retinal thickness, and we had a control group that didn't do any artificial gravity on the centrifuge. And we had 2 different versions of artificial gravity, one that was continuously spinning for 30 minutes, and one that spun intermittently for about 5 minutes on, 5 minutes off. And we saw exactly the same amount of edema in all 3 groups. And so we learned that 30 minutes was not enough to develop the edema, and that we may need significantly longer amounts of time in a countermeasure to prevent these changes from happening. Now, this was a longer study than the first one that I shared that was only 30 days. And here we saw the development of choroidal and retinal folds. And so right in the middle of this screen in these red and red box and circle, and it's very small and it's difficult to see, so I apologize, but there's little wrinkles that developed in the top of the retina and the choroidal folds that began to emerge in the bottom layer. We saw this in about 25% of these subjects. So here in this analog, we developed yet the second sign that we've now observed both in astronauts during spaceflight as well as these subjects participating in bed rest. So, you know, we have found these ocular changes. We have a lot of equipment in place to try and understand what may be happening. And we now have a way to study this in bed rest, which is going to be really helpful because we can start testing other countermeasures. We have another study planned to start next year that will test lower body negative pressure for longer durations of time. We have a team of people who've been looking into, can we develop a sleeping bag style sac that does the lower body negative pressure that maybe we can implement while they sleep for prolonged periods of time. On the center picture here on the bottom, we have thigh cuffs. These are used to try and trap blood in the legs. It's something that our Russian colleagues use during spaceflight currently. That's one way we've thought about trying to reverse the fluid shift, and we have some planned studies using those thigh cuffs. And then there's a team in our nutrition lab who have identified some possible links with B vitamins and and that there may be certain B vitamins that individuals are lacking that may make some individuals more susceptible to these findings. And so there's a whole line of research trying to understand if some of this may explain the individual variability. Why do we see some people that have huge amounts of edema and other people who have none at all when they've both been in weightlessness for similar periods of time? So lots of different questions that we're looking at and trying to tackle simultaneously. And then I do want to finish here by saying that, you know, we're just one arm of this tripod where we do this research, but we work very closely with our flight surgeons in the space medicine division, as well as our colleagues in the epidemiologists who are tracking for the long-term health. So we have a number of different projects who, once the astronauts come home, we want to track how their vision and the ocular structural changes are over the course of their lifetime to see if there are delays that perhaps they get through their mission fine, but we may start seeing some changes develop later in life. We're trying to track that as well. And with that, I'm just going to say thanks for the short period of time I got to share this with you today. I had the luxury of being able to chat with you all today, but there is an enormous number of individuals behind the scenes who led to a lot of the data and the story that I was able to share with you today, both at NASA in our laboratory, as well in Germany at the German Aerospace Center where the bed rest studies have been conducted. So with that, I will pause and I'm happy to take any questions anyone may have for me. Thank you.
Sir,
Yes, please.
so I have one question from Tom Zapparini. Ophthalmologist doing research on veterans exposed to repeated blasts, TBIs find retinal changes in tons. Do you cooperate with these researchers?
I heard retinal changes and then I missed the part of that. They have TBIs that induce retinal changes. Is that correct?
So let me try to read that. It says ophthalmologists doing research on veterans exposed to repeated blast TBIs find retinal changes, and then it's TONS. And the question is, do you cooperate with these researchers?
I see. So we do have some collaborations with some folks in the Navy and some other areas, but right now, those types of changes are so different than the kind of changes that we are seeing. There hasn't been a direct overlap in the types of work that those groups are studying and our groups are studying. So we don't have any ongoing relationships with them on those types, but we have done some investigations and some work with, I think it's the Navy that we've done some work with.
Great, thank you.
Mm-hmm.
So yeah, Tom is just clarifying that TONS is traumatic, or actually Dr. Mazzoli, traumatic optic neuropathy.
Oh, okay. Yeah, I'm not familiar with that.
We didn't know what that was.
Thank you for the clarification. Yeah, I wasn't familiar with that term either. But you know, we are interested in trying to understand if there are various optic nerve pathologies on Earth that we can use to learn more about what we're doing, or if what we're doing can be applied to other areas. When this all first started, the assumption was that this was related to something on Earth called idiopathic intracranial hypertension, that elevated pressure in the head. We don't believe that that is really a perfect analog for what we see. And we, so far, think that what we're seeing is a very unique pathology that is unique to spaceflight and now perhaps bed rest. But we would love to find, even if there are partial overlaps, with other conditions on Earth, and are always interested in discussing these ideas with other individuals. So please feel free to reach out if we think that there may be opportunities to find areas of collaboration.
The next question is, are the subjects of the studies astronauts or are they non-astronauts when attempting to simulate on Earth, such as the tilt table?
Yeah, great question. So the subjects that participate in the bed rest studies are not astronauts. I think some of them are interested in becoming astronauts, but they are not astronauts. But there are criteria that they put in place to try to make them astronaut-like. So there are fitness standards, there are health standards, weight and height standards, and age standards to match what would be like an astronaut. So we are not looking for, an obese, somebody who is not in good shape kind of a thing. We want them to be of similar condition to astronauts.
As you mentioned, nutritional aspects, one DoD researcher has some evidence that nutritional changes can mitigate blast retinal damage.
That's very interesting. I'd be interested in understanding what kind of nutrition aspects they're interested in, and could certainly try and link them with our nutrition team as well. Our nutrition team has found certain genetic variants that they think are slowing some enzymatic pathways and therefore basically putting the eye in a position that's a little bit more at risk. And then once the stimulus of the weightlessness and what we believe is the fluid shift, because the fluid shift is probably similar between bed rest and weightlessness. We think it requires this stressor of the fluid shift, but then this very risk and is susceptible when they encounter this, and that a certain cocktail of B vitamin supplementation in these individuals would perhaps provide some level of protection. So I'm not familiar with what the nutritional aspects are related to the TBI, but it would be interesting to see if there was any overlap there.
I guess Tanya Rex, PhD Vendy, has published it, but the citation's unknown at this time. Sir, is there more retina changes in those who are at ISS longer than 6 months to a year versus shorter periods?
Yeah, that's a great question, and it's one that we are very interested in. A lot of people from the media are probably aware that we had the 1 year, Scott Kelly flew the 1 year mission along with his colleague Mikhail Kononenko from the Russian Space Agency. But we have actually had two other astronauts who recently have performed longer duration missions closer to 1 year as well. We see quite a bit of variability between individuals. In some cases, we believe that there may be a component that the longer the mission, the more likely it could develop in some individuals. But there are other individuals who, even despite a very long mission, never really showed any changes. So we do intend to fly more 1 year long missions to directly answer that question and get a higher number of subjects doing longer duration missions to understand if we're going to see either a higher incidence or a greater magnitude of change. Because when we fly missions to Mars, it will probably be approximately 3 years round trip. And it's that duration that makes us nervous. In general, we now have enough experience with 6 month long missions that even though we see edema and chorioretinal folds developing,
You're saying I'm supposed to.
we believe that it is not going to be damaging the long-term health of the astronauts from the research that we've done so far. We feel relatively comfortable, even if this develops in 6 months, when they come home, they're able to recover from that fully. We don't know if when the edema is present for longer, 1 year or 3 years, if they will be able to recover. And that's really the big unknown related to this condition right now. Well, if there aren't any more questions, I know that I'm going to stop sharing my screen here. And I know that, that Tracy had some slides, or it was going to give a short talk here as well. Tracy, if you're ready, I'm happy to hand it back to you. So while
hi, we actually have one more question.
Okay.
Tom, you can go ahead and ask your question.
Oh, I was just curious if there was any long-term visual acuity changes, like, you know, somebody's 2050 or 2070 versus when they launched and went up, their vision was 2020.
Yeah, also a great question. So in short, the largest change that we have seen within a 6-month mission was a change of 2 diopters. And I think in general, for the people who have had changes of between 1 and 2 diopters, there has been some degree of a partial recovery, but it has not fully resolved. That some of this seems to be permanent. But it isn't, like I said, the greatest one we've seen within a single mission has been 2 diopters, which is substantial for a 6-month mission, but is also has been fully correctable with glasses.
Well, thank you for your questions. Thank you very much, Dr. Laurie. And maybe it is time we could go ahead and turn it over to Tracy. I don't think there's any more questions right now. So yeah, thank you. I don't know if you're going to stay with us, but if you can, we'll do a little closing at the end also. Thank you so much for that.
Yeah, well, I appreciate the invitation to come and share some of this with you. So it's been my pleasure. So I can do a brief intro for Tracy here. Tracy Minish graduated with a Bachelor of Science in Computer Science from the University of Georgia, and he's worked at NASA for over 36 years. He was a space shuttle instructor for 15 years, a NASA branch chief, ground segment control board chair, and is currently the Mission Control Center ops manager. Tracy has served as the No Boundaries chair and is currently in charge of No Boundaries outreach. And he has retinal pigmentosa and is legally blind. So Tracy, looking forward to your talk today. Tracy, we can't hear you right now. I think you're still on mute.
Now, can you hear me?
Yep, we're good.
Sounds great.
Perfect. Hey, just for a little quick thing, Stephanie McMahon is with us from Space Center Houston, and she is in charge of inclusion and outreach for Space Center Houston. That's the visitor center we have here in the Clear Lake area outside of Houston. And I'm just going to put in a quick plug that if you have your convention here in 2023, we will give you a behind-the-scenes tour of NASA and also some special things we can do at Space Center Houston that are pretty great. So I thought I'd turn over to Stephanie real quick. She just had a little short thing, and then I'll pick up because she's not going to be able to stay with us till the end. So Stephanie, you have the floor.
Well, thank you, Tracy. I hate to jump in on what you're saying. That was fascinating listening to Dr. Laurie. I learned quite a bit. I'm quickly sharing a screen. These are some things that we have to offer guests at Space Center Houston. So again, the official visitor center for NASA Johnson Space Center for guests with low vision and blindness. I just wanted to talk about a couple of things. We are IRA-free zone. So if you are an IRA user or any of your people you know use IRA, free minutes absolutely included for everybody. So IRA is a service that allows guests to explore independently. It's like having an extra pair of eyes with you from highly trained people. You know what? This is not the right presentation. So I'm going to stop sharing my screen, and I'm just going to tell you about what we offer. That's embarrassing. So it happens. So what we have to offer people, we have, again, the IRA free, we've got tactile experiences. So if this is by request only at the moment because of COVID. So we can pull out 3D models, we can pull out Braille and tactile books. We have other opportunities when we know it's a group that is coming, and we know ahead of time. I could even pull out some really cool artifacts to touch. We have this Space Center Houston app, which is a fantastic app that is very accessible, uses text to voice. Mechanics work extremely well with it. But what's really neat about it is we have a location-aware tour. So we have over 300 beacons throughout the center. So as you approach a different beacon, it automatically lets you know what is nearby and can read the information to you about what is nearby. We also have in-person experiences. So again, if you are to come to Space Center Houston, we've got camps. We've got camps for ages 9 and up. It's called Touching Space. That is a one-day camp. And we do all kinds of really neat things, including using liquid nitrogen and model rockets and all sorts of things. We have Space Center University, which is our premier education experience, and we can do for middle school, high school, or adults. We have a version of it designed with people with visual impairments in mind. Although like this week, we have a typical Space U going on, and we have a young lady who is legally blind attending a typical camp. And then we also have field trips, corporate events, team building, family outings, all that sort of thing that are available to our guests with low vision blindness, as well as other, of course, disabilities as well. And then we have some really amazing virtual group experiences. So if you wanted to do something as a group, we can do a virtual tour of Starship Gallery. Recently, we had the National Federation of the Blind had their convention, and we did a tour with them virtually, which was a lot of fun. We also have distance learning programs. We have programs designed all the way from kindergarten all the way through adult, again, tailored for people with low vision and blindness. So again, just kind of a little bit of an overview of some of the things we offer at Space Center Houston for people with low vision and blindness. If you have any questions about that, again, my slides are the wrong ones. I apologize. That was the training one we're using on training our employees on how to use IRA. That was the first slide, and it looked exactly like the other one. But my name, again, Stephanie McMahon. So it's SMCMAHON at spacecenter.org. You can reach out to any of the people who you got this invitation from. They have my contact information, and I'm happy to chat with you about what all we have to offer. Anyway, thank you.
Anybody have any questions for Stephanie? I would just say book your tour for when you can get here, or 2023. So if y'all are ready, I'll go ahead and get started. Is that good, Tom or Stuart?
Good.
All right,
Yep,
great.
good. Yep, please go ahead.
My name is, and if you have a question, I don't know if you want to hold them for the end. I'll let Tom and Stuart kind of control that. But my name again is Benjamin Tracy Minish, but I go by Tracy. And I've worked at NASA 36 years and had a great career and still going strong. The thing I'll just start off with is that RP, or retinitis pigmentosa, if you're not familiar with it, it's a disease that slowly kills your rods and cones, decreases your peripheral vision, and then it finally takes away your central vision. So in my right eye, I really cannot see. Sometimes I can see light dark. This eye, I see about less than 5%, about 40% of the pixels are missing. But I am very excited. There's a lot of research going to end blindness. There actually is a challenge to end blindness in 2020, and some amazing things are being done. So I actually, my family, we actually gave some spit, we gave some blood, and we gave some meat to get our DNA tested and get it identified. And I actually have PRPL31. So that's the DNA defect I have. And so I take it and I've told my wife I want to get it printed on a t-shirt, printed on a baseball cap, even have it maybe embroidered on my boxer shorts or tattooed on me, because I think one of the keys is if you have a genetic defect, it's knowing what it is and get registered in the retina tracker. But I'll just reach out to our veterans. If you have an eye disease, you still want to get registered in the retina tracker, because in March they started another phase study called the bionic eye. And what they do is they go beyond your retina that can be damaged, and they're taking the ganglia behind it. And what they do is they use cameras and glasses and an implant, and it transfers the image to those ganglia. The brain is really what sees. All it has to do is have the electrical currents to go back to the brain, and then it'll tell you what you're seeing. So there's research out there, even if you have something that's not a genetic defect, to cure your blindness. So I really believe my great-grandmother, my grandmother, me, one of my sons, I had 3 sons, one of my sons has it, and we just had our first grandson by that son. And so I am confident that he will not lose his vision before he gets in his teens. I think we're really on the verge of some amazing things. So you can go to the Foundation Fighting Blindness, or you can Google Retina Tracker. Of the 200,000 people that have genetic diseases or blindness in the United States, only 5,500 have registered. And what I always tell people is that numbers drive interest, interest drives funding, funding supports research, and research provides cures. So the more people out there, the drug companies are more interested in doing that work. So it's just a little thing for us all to think about. Also, I want to tell you there's some special hiring authorities we have for our veterans, and we also have for people with disabilities. So I sent Tom and Stuart and Kyle a little PowerPoint presentation that has more information than I'll go into. But what they have, if you have a disability and Legally Blind certifies you for it, then you can fill out this Schedule A form, send it to NASA, really send it to the government. And then when I was a branch chief and doing hiring, then they can come to me, and if you qualify for some kind of job I have, even if I don't have an opening. So say I have an engineering job where I need someone to train astronauts, somebody that's a good teacher, can do that type of stuff, then what they can do is they can give me to go above my budget and hire you. So I think that is just a great opportunity that a lot of people aren't aware of. The second thing they have, I know a lot of people, when they leave the military service, they go back to school. And when you do that, we have internships at NASA. So I sent some information on that. And there's a wonderful lady named TQ who's over that. And you can send her your resume. There's a presentation that I sent out to Tom and Stuart and Kyle that actually has information of when we do that. And what you do is you'll come work at NASA, and then you go to a semester of school back and forth. And they really encourage that. And we're really trying to reach out to be more diverse, more inclusive. So that's an opportunity. Instead of thinking I'm just going to go straight through school, then you can toggle between going to school, working for NASA. And I'd say we hire, I think it's 25% of those interns. I think we really try to hire them all. You know, if you work for the government, as y'all know, that sometimes you're not making as much money as you can make in the private sector. So we have to battle for those interns. And then the last thing I will mention on this topic, if you are a veteran and you apply for jobs, so we put jobs out on USA Jobs, you can go out there. If I put a posting out there and a veteran qualifies for that job, I don't see any of the other resumes. You know, it's kind of funny to say, my eyes like, I don't have those other resumes sent to me. Those, you get priority hiring. So if I put out a position for an engineer, a veteran applies, you have to meet the qualifications. If you meet the qualifications, that resume comes to me, just text something, and it will, and we will hire you. So I'm just saying there's some opportunities out there. Make yourself aware of these things because they're not always well advertised. And there's some things that, you know what I always say, all I want is opportunity. I'll do the rest. If you can show me where the door is, open the door, I'll do the work to get through it. And I think that's what all of you want to do. So I just want to make you aware of those type of things going on. So at the end, I can answer questions on that. I'll just give you, if you got a pen handy or you want to type it in, my phone number is, and this is my cell phone number because my work phone, I'm on call 24/7 for Mission Control Center issues. So I always have my phone forwarded, but my cell number is 281-974-7954. And my email address is Tracy, Tracy, .B for Benjamin, and then it's Minish, MINISH @nasa.gov. If you send me something there, I can forward it to you to TQ. But if you'll look at that presentation for the ones for getting that Schedule A hiring, TQ's the person, but I don't mind for being the throughputter for that. So now I'd like to kind of change subjects and tell you a little bit about my vision for space and some of the wonderful things we're doing with your tax dollars, because everybody's always interested, what are you doing with my money? So NASA, I think, is a great investment. And I'm going to start off with a couple of things over here. Is this the Earth? What? Okay. Got to get the right planet. So I think y'all all heard about, we just had our Bob Behnken and Doug Hurley, two of our astronauts, fly on the commercial SpaceX Dragon rocket, and they went up to the space station, and then they've already come back down, much like we did in the Apollo in a capsule, but totally different, totally updated. So the commercial program, NASA's partner, and it's really a win-win, a win that we're getting more investments into space. We're doing things here. So what we always like to say at NASA, we flew American astronauts on American-built rockets launched from American soil. You know, the Russians did good for us for a while, filling that gap from 2011 up to now. One of the things I thought was so wonderful is that when Doug and Bob got to the space station, the last shuttle mission when we had it, they actually put a US flag right there on the hatch. And when they came up, they took that flag down, that American flag, and they brought it back down to Earth. So we were waiting for us to get back and be flying our own astronauts. So one of the things we do also with your money, and NASA does, is we're at a space station. So we're studying the Earth. We're doing research for some of the fires. I don't know if you heard, there's always fires in California, for some of the drought conditions, for how we can, you know, make the planet last longer or be more efficient and stop some of the things that are happening to the planet. So we study that. The space station is going around the Earth at 17,500 miles per hour. So we see 16 sunsets and 16 sunrises in a day, an astronaut does. That's pretty amazing. Every 90 minutes they go around Earth, and they're doing this 260 miles above the Earth. So, and the reason I'm wearing this thing, and I'm going to take it off, is just to emphasize that when they're up there going around, it's a giant laboratory. So we are not up there just, you know, trying to set a record or look at the stars. Though we do look at the stars, we're actually doing research there, as Dr. Steve said. So I'm going to take this lab coat off. That was just to show a little demonstration of that. Here's the Mars. So I have my hand, the Mars right here. And in Mars, I think everybody's aware that on July 30th, we launched another rover. We already have a rover on Mars, but we launched a rover to Mars, and we launched it on July 30th. And just to show you how long it takes to get there, it will not arrive there until February the 18th of 2021. So that's a pretty long mission, and that's one of our challenges. You know, some things are just science. You could think, oh, we could do that, what they did in Star Trek, you know, warp speed, or you just move, but it actually takes a while to get there, about 6 months. And so we've sent a rover there, and it's called Perseverance. And what's so cool about it, it's actually going to take samples, take samples, and then it's going to encapsulate them, and it's going to drop them, move on. And we have another rover that we're planning in 2022. We'll actually pick up these capsules, and it will bring them back to Earth. So we have samples of lunar surface, lunar rocks and things, but we don't have anything from Mars, and we're looking for micro life forms that were there ancient and before. So that's one of the things we're going to be doing with that rover. The other thing that's super exciting is that it actually has a helicopter called Ingenuity. and that helicopter will be dropped from the belly of that rover. So it will drop down, the rover, of course, move out of the way, and then it will fly. So it'll be the first time we've done power flight on another planet. And that's pretty exciting, because one of the things, some people say, why don't we just send rovers and those type of things and do research? Well, when we have a rover, it takes, human can probably move in like a week and do as much as a rover can in a year, covering territory. Rovers move very slow. It's very difficult to do that. And then also, if we find something of interest, it's a lot harder to get that rover to go where we want. As smart as artificial intelligence is, all of us, we are better. And I like that. And I don't know when we'll get to anything that's not, because they can only be as good as we provide them. So I would just say that's going to be great. And just give you a little bit, that thing could fail. We learn a lot from our failures. If you look at that rover, you think 1/3 gravity on Mars. But the helicopter, that goes around, there's 1/10 of the atmosphere. So when you do a helicopter, y'all are probably very familiar, that it has to move air to get lift. Without that air, it's going to have to spin super, super fast. And so the offset of that less gravity is not quite as good as you would think, because of the lack of atmosphere to move it. So anyway, we're doing missions to Mars. I also thought I'd tell you we have something that's called, NASA, a lot of times people forget about aeronautics. We're doing a lot of things in aeronautics. So we have all-electric plane. It's called the X-57, you look it up. And Tesla is going to be jealous, but it's totally electric. Because NASA's always trying to do 3 things. We want to fly safer for our commercial things here on the Earth, or any flights we have. And we trade a lot of things with the Department of Defense. We also want, besides that, we want to fly faster. And we also want to fly where there's less carbon output. So we have something called the X-59, and it's called the supersonic quiet jet. So, when somebody breaks Mach 1, they always make a big bang. That's one of the reasons we don't have all these things. So we can cut your travel time in half with this plane and this research we're doing. And wouldn't that be nice, especially on your longer trip, because they can take a lot of time. Now I'm going to talk to you about, I'm going to hold this one more second and talk to you about DART. I like the acronyms NASA has, and I know the military has them and other things do, but DART is the Dual Astro Redirectional Test. And so what we're doing in 2022, there's always the risk that an asteroid could come and hit the Earth and cause major, major damage and even wipe out life here. So what we're doing in 2022, we're actually going to an asteroid and we're going to actually move it. We're going to move it over and change its course that it's doing. And we don't have to move it much. So if you look straight at you, a straight line in an asteroid is coming towards Earth, we move it a little, depending how far out it is, that little change could take it way away from Earth. So that's something we're going to be doing in 2022. I'm super excited about that. And then also we have something called the James Webb Telescope. Everybody's heard of Hubble. The next generation is called the James Webb Telescope. We had it here at Houston doing vacuum chamber stuff with it. That telescope is going to rock the socks off of Hubble. It will let us look back to the beginning of time. That's supposed to launch in November of 2021. And then one of our things we're super excited about, and this is the moon. If you can't see it, I'm holding up inflatable of the moon. What we're doing with this is we have the program called Artemis, is the twin sister of Apollo, and we plan on having the first female put boots on the moon in 2024. And I always like to tell people, being from Texas, that those are cowgirl boots that will be touching down. And of course, we'll have other people going with that. So what you may not know, because we're focusing here to 2024, next year in July, and it's early July, and we really think we can make this, we're going to have the Orion rocket, and it's going to go out and it's going to circle the moon. So for the first time since Apollo, we will have, and we won't have humans on it because it's our test flight, but it'll go around the moon and come back and show we have that. And what I have is 2 rockets here. see where they are. Here's one. So what I'm holding in my hand is a Saturn rocket. And if you'll notice, on the shuttle was quite different. We had 2 solid rocket boosters attached on either side. But the thing that was special about Apollo, we put the crew at the top. Mike Griffin was our administrator at one time. He said, we need to put humans on the top of the stack where we belong. What we had on the shuttle, if we had the shuttle crew kind of parallel in that shuttle model to all the fuel, all the hydrogen and oxygen, which is very liquid hydrogen, liquid oxygen, very explosive. Had them up here, we could jettison and do things. So Saturn had this build. So now what we did, we actually took the shuttle and we took the Apollo and we kind of mixed them together. So this is what we call the SLS, and this is called the Space Launch System. And this has the power to get us to the moon. We also believe this can get us to Mars. And what we have is here is fuel in here, rockets engines here, different stages, the crew on the top, like Apollo. But what we've added is 2 solid rocket boosters on either side. So if you're looking at this, then you can see a stack, if you've ever seen a Saturn or know about it. And on the side, we took things that were on the kind of side of the external tank, and we have 2 solid rocket boosters that can really get us going when we have to break from low Earth orbit and really get that thrust. So in that way, we have rockets down here, 4 of them, and then we have these big rockets on the side. So this is what we're going to be launching in less than a year. So with all this, you say, oh, that's where my tax dollar is going. But NASA, out of your tax dollar, oops, your tax out of 100 pennies, I throw out pennies. I put 100 pennies in my pocket. Y'all throw in some pennies. A lot of pennies. One left. NASA uses less than really about a half of 1 cent of your tax dollar. So really are a good investment because we do a lot of research that you probably don't know. We publish a magazine every year that has what we call spin-offs that people can actually use to develop businesses, but also benefits we do for the United States and then for the world. You know, the space station is an international space station. We actually work very closely with the Russians, with the European Space Agency, which is 10 countries, but French, Italy, England, those are some of the main ones we do. And then we work with the Japanese, and we're also working with Canada. So I just want to make that little bid for you. So I thought I would now kind of change directions and talk a little bit about my thoughts and things, and not as much on NASA. So I'm going to try this because we have to. So let's see how this works.
Speech on. Try again.
I'm turning on my phone, and it always aggravates me when it tries to make me do passcodes.
Voiceover off.
Hold on. Just a
Voiceover
second.
on. Photos no. Messages. MAH 300.
So I have the. It's coming up.
MAH. Touch ID for Try again. Passcode. MAH 360. MAH 360.
I will get this up in a minute.
Try again.
All right, it worked.
Unread. Invite. High important. Unread. Unread. Price. Unread. A. Heading. Unread.
So this is some technology I used to read mine. I was actually going to play you, and y'all know this well. I had it called up, but it's closed since I was sitting over there for a good bit of time. I was going to play the thing everybody can remember if you're, a lot of y'all were born after this, but in 1969 on July 20th, when we actually landed, Neil Armstrong made those words, one small step for man, one huge leap for mankind. So what I like to tell people, as great a man as Neil Armstrong was, if we had filled NASA with just clones of Neil Armstrong, we would not have been able to accomplish that great feat. It took different perspectives, diversity of thought, and unique problem-solving skills to be able to do that and pull it off. I like to tell people that people with disabilities, we are great problem solvers. We do it all the time. It's just part of our life. We kind of, it's in our DNA. There's a song by Bob Dylan that says, "The times they are changing." I look at the unemployment rate right before I came here, and people with disabilities have about 2/3 are unemployed that have legally blind or vision impairment. And I think that is really changing with all the technology. So let's see if I can find right here. So I'm gonna play the Bob Dylan song. You can go look it up. The times they are changing. It's kind of relevant to today. So that was my little harmonica thing. The times they are, I would have to hold my nose to sing like Bob Dylan if any of y'all remember him. But I really think things are changing. All the tools I have, you just saw my phone reading to me. I can actually sit there. I have headsets that I wear that go around here. I slide into my ear. So I can be in a meeting that I think, this is not really relevant to me. I can be underneath the table. And actually, because a lot of our meetings, we tell people, laptops closed. We want you to concentrate on yada yada. But sometimes that's good and sometimes you don't need to. So I can be doing my emails down here with my phone with a thing and just tapping, touching, and moving everything. I have I use screen readers. I have a thing here called a Pebble that blows things up for me. I use AI as a reading tool. Put my phone over my mail. I want to be able to go through my mail myself. All these assistive technologies really are leveling. And what I think we got to do is educate the general public. We got to educate, most importantly, employers, and we got to have it so they know that we have something to contribute, that we can actually contribute more because we come from a different angle. We use different tools, and our brains have been developed. Each one of us is unique. So what I thought I would also do, one of our technologies, NASA, one of the things for mobility is the cane, but Alexa, play. Alexa, unpause. Should you tell that one too?
Alexa.
Alexa, continue.
Alexa, sorry.
Tell her to set the volume to 10.
Alexa, turn volume to 10. Sorry, there is nothing for me to resume.
Oh, sure, that. Oh, there you go. So, what I'm holding in my hand is the cane that NASA developed. We actually ripped this off of Darth Vader when we defeated him, and he came to the good side. So, what I'm holding in my hand is actually a lightsaber, which I think makes a great cane for the dark. Alexa, stop. So that didn't work quite as well, but I'm trying to put in some of the assistive technology just to show you what we're doing. I'm going to hand this way over because I don't want to drop this and it cause, cut through a hole in my floor or something. So getting back on course, there's so many different things of technology. And what I always tell people is become like a ninja. Become one with the technology. The more you know how to use it, the quicker you can work. You'll do better than me, and I demonstrate on here. And you'll be more productive. If you're more productive, then your employee is going to love you. So that's what I try to tell people is just become really familiar with your technology that you're using. So I'll just go back when I tell you a little bit about my history. When I started out, I was already legally blind. Even when I was starting college, I couldn't drive at night, but I was pretty good at thinking things and getting by. So I still had a driver's license. But I told my counselor at college, I said, I'm losing my eyesight, but I love math and science, and I want to go in math and science because that's where my strengths were, and that was my passion. She strongly discouraged me, said, no, you will not want to do this. You won't get employed. You need to go into counseling, which is a great, one of my kids is a counselor. But when in telling me that, and so I just kind of ignored her, and I decided I wanted to go into math and science and did that. And I've had a 36-year career with that. So I would just tell you, when you have somebody to tell you, you can't do that, just think of your inner self. Look at what you know yourself better than anybody else is going to know. And just do not let that set you back. The next thing I want to talk about is when I got here to Houston. I needed a new doctor. So I went to a doctor. I tried to, do a little research. Back then, you didn't have the internet. go to the doctor. When I finish the exam, the doctor comes out and says, hey, you qualify for disability. So I'll help my nurse come in. She can help you fill out all the paperwork. So I thought about it. I thought, you know, I just spent, it took me 5 years to get to college. My wife and I were working our way through college. And I thought, no, why would I do that? I have a degree. I want to go out and use it. And so I kind of ignored that doctor and I changed doctors. So you're going to have people, when you have a disability, that sometimes aren't as encouraging as you would like, or they try to, what I tell kids a lot of times when I go talk at schools, they want to keep your eyes down. They don't want you to look up, look over the horizon and dream big. So I would just tell you, if you've gotten a disability from war injury, or if you even have, there's a lot of people that maybe get macular degeneration, some that hit people as we age, or even if you have a retina disease like I did, we're in the military and your vision is going down, do not get discouraged. Just there are lots of opportunities, lots of things you can do, especially with assistive technology. There's a Bible verse I thought I would share with you real quick that has always helped me. It says, to keep me from being conceited, I was given a thorn in my side to torment me. But I was told, my power works best in your weakness. So I'm now proud to boast my weakness, because when I am weak, then I am strong. And I really feel in a lot of ways, having RP has made me a better person. I would never wish RP or any of the things that happen with disabilities on anyone. But sometimes I feel like I'm almost like a sports star or a movie star. If I did not have this, y'all wouldn't be listening to me today and I wouldn't have this opportunity. But also with my employer, they look at me and they may make judgments on somebody who knocks on their door next. It could be my son. It could be my grandson. So I feel like I'm a role model. I don't make the money the big stars do, but I am, the way I carry myself and do my job will reflect on maybe the opportunities that are given someone else. They go just a little bit further. There are 3 myths that I try to break down about disabilities I've heard of. And the 3 myths are these, and I'm sure there's others. One is that a person with a disability will be a low performer. And survey says false. They really perform at the same level, judged by the same standards. With all the assistive technologies, it is level the playing field. Second myth they have is that people with disabilities have high absentee. In other words, they miss work a lot. So I've worked at NASA, and I probably have helped, you know, skew that thing a little bit. But I've worked for NASA 36 years. I have 8 hours of sick leave I've used. One thing, I'm very blessed that I'm healthy. You know, my eyes aren't so healthy, but the rest of me is. That 8 hours, I had projectile vomiting. That's the only reason I miss work. If I'm scheduled to go to work, I go to work. I'm blessed I get a lot of vacation, so I get some rest. But, and you know, being an engineer, I was actually able to measure, I think I got 5 feet back from the toilet, was still able to hit it. Probably a little bit too much information for you, but did that. So I thought I'd just go a little bit further. I had a hard time disclosing my disability. Some of you may have, your eye may not get worse as you go along and be employed. I really struggled with that. I was memorizing everything I could. To give you an example, I went to flight readiness reviews for the shuttle, and I had to present. So I would show up 30 minutes early. The night before, I would fast. I wouldn't drink or eat because those meetings could last 7 hours, and they said, oh, if you need to take a break, get up. I couldn't get up and get back in the room because it was dimly lit, and I was usually positioned up at the front since I was presenting. And so what I finally did is I realized I was working too hard. I was working 12 hours because I wasn't using assistive technology. And I finally came and started embracing that. I then was afraid my employer in NASA might start taking away opportunities or even reduce my work. So even after I did that, I went to my division chief and said, I've been doing this flight software branch chief job for 5 years, and I feel like I want something new. So he came back and said, hey, I have an opening where you could integrate all the control centers around the world and have them come, because when the Russians send commands, the Japanese send commands, the Europeans over Germany. They come to Houston. Houston sends in a white sand. White sand sends them up to the satellite. Satellites flip them over and they go to the station. Telemetry does the same course. So I actually took that job, and he asked me, this is what I loved and what employers should do. He said, do you think you can do that job? He didn't make the decision for me. I went back, talked to my wife, and we said yes. And so I ended up going to Moscow, to Tokyo, to Roma, going to Montreal, all over the world. And it was just a great opportunity. So I'm going to go ahead and kind of wrap this up. And I have this little experiment I do with kids. And I just think it's a good demonstration that I'll share with you. A lot of times we're going to face barriers in our life. And so I have in my hand a big potato. I mean, it is rock solid potato. And then I got a straw. Now, I wanted to go Chick-fil-A. They have some really great straws, a little more sturdy. But this is one I think from a Barrera. So I just unwrap the straw. And when I talk to kids, I do two things. I first talk, I have about 15 science experiments I do. You know, it's kind of interesting when you do them when you can't see it. And we do some where we light things up on fire because we show the flash point. We use dry ice and freeze things to show the harsh reality of space. We launch off rockets of different sizes, different shapes that are homemade. I did an experiment with eggs. But on this potato one, I really love it because it has a life lesson. Think of the straw as your plan, I tell kids. You're starting at one end of the straw, and you develop a plan to where you want to go. Lots of kids dream, and they dream especially when they're younger, but I think we can still dream even at our age, especially mine, you know, being soon to be 65. So you develop a plan, and then you have to go through. But once you develop the plan, you still got to take action. So the physics of this is force equals mass times acceleration. A very small object going very fast can create a big force and cause it to go through. So what I'm going to do is I have the potato, but what I tell kids is when you develop your plan, you need to keep it in front of you. You know, put it somewhere, tape it on your mirror, it's old school. And maybe put it on your calendar. So every month it comes up and you adjust. Oh, I thought I was going to be here, I'm back here. Make that plan and then you execute it, you take action. So if you can see, I just stabbed through and it went straight through this potato. And it's just one of those things I like to share with kids to get them motivated to go do something. So I'm going to end with a little speech I memorized. You know, when you don't watch as much TV, you do other things. So I've memorized, you know, the Sermon on the Hill. I've done Martin Luther King's speech many years ago. I memorized his I Have a Dream speech because it just spoke to me. But I'm going to use the Braveheart speech. It's the one where he's about to go into battle. His army is outnumbered, and he's trying to get them to take action. So it starts off, I am William Wallace, and I see before me a whole army of my countrymen and women here in defiance of tyranny. You come to fight as free men and women, the free men and women you are. For the rest of us, not you, I'm saying to us, what would you do without challenges in your life? Will you fight? No, we'll go home and we will live. I go home and you will live, at least for a while, dying in your bed many years from now. But will you be willing to trade all the days from this one to that for one chance to come back and tell your children and your children's children, I decided to give, I decided to serve, I decided to live, I decided to love. And as Gene Kranz said during Apollo 13, failure is not an option. So that kind of completes my presentation. And I was going to open it up for questions. I don't know if Dr. Steve is still on or Stephanie. I would just say I am honored. I am humbled to be here. Not knowing you, but just a short time I've gotten to know Tom. I think we're going to be lifelong friends. He lives in Pearland. When the pandemic is over, we will share bread and liquids together and tell life stories. He's a wonderful leader. I've enjoyed meeting him. I appreciate all you do. Anything I can do to tell you how I cope with things or what I'm doing or some way to point you something, I am happy to do it. So I'll be quiet.
Tracy, this was phenomenal. We have time for just we have about 4 more minutes left. If there's anybody that would like to say something or ask a question of Tracy. Steve had to go to another meeting,
Right.
so he got off just a few minutes ago. But do we have any questions? Put them in the Q&A or raise your hand, please. I think you maybe inspired us so much we're speechless. Anybody else? If not, we'll just go ahead and end this. This was fabulous, and Stephanie and Tracy, both. This was a phenomenal 90 minutes for us, and I just want to just a heartfelt thanks for sharing the amazing developments in research, and Tracy for your perspectives and your experience, and sharing what you've done. It's just really, I'm very motivated, and really appreciate you taking the time to share this with us. And also for Stephanie for sharing all the
Jerry Hogan has his hand up.
opportunities at NASA. So,
Hey, Stuart,
yes. Oh, we do have one
we
question.
have a hand up.
Okay,
Yeah.
go ahead.
Jerry Hogan.
Jerry Hogan.
Zoom webinar.
Can you hear me?
Yes.
Yeah, Tracy, Jerry Hogan, in San Antonio.
Audio now unmuted.
You guys done a very good job. Thank you, and thanks for inviting us to share your and everybody share the NASA experience. I didn't realize that you guys were doing that kind of test with the eyes in space and stuff. So very, very intriguing. So appreciate it. Thank you, and you keep up with the good work.
All right, thank you.
I'm also a blind vet with RP with Usher.
Yeah, they're doing a lot of studies on, I think that one in particular. I'm hoping I'll be in a study soon. They're starting to do a little research on the PRPF31.
Tracy, we had one comment in the Q&A box that just said this was a really inspiring webinar. That's from Scott Shazinski. He's from Southern California. Just really appreciate what you've done and what you've inspired us with today. So if there's nobody else I see one more. There's another hand up, or is it gone now?
It's gone.
Okay. All right. So well, thank you very much. We do have some more sessions planned for next week. The next time we'll be on is next Tuesday, August 18th at 1:00 p.m. Eastern Daylight Time with the same link. So Tracy, thank you again. Thank you, Stephanie, if you're still on. I really appreciate your contribution today and for inspiring us. And thanks for all those that have attended as well. So we'll be back in touch with you guys. Thank you again.
Hope to see y'all here in about 3 years.
Hopefully we'll be able to do that.
Right.
Thanks again, Tracy.
Thank you.
Stay safe and have a great afternoon.
Y'all too. Thank you.